Hi, I guess we should get started. The time is there. Let me see. Um, so, so in first class today. So basically, the first class for upcoming semester for 2011. This is basic stacks for business, and it's required class. So regardless if you took it from me or you're going to take from others, then the content will be same. So I hope you have seen the course outline that I will go over very quickly, and you can ask me even a question, and let's get to it. Okay, so some self-introduction. So probably you see me, I'm Chewy. My surname is Cole. I'm in the CYT building, 9th floor. So originally, I also undergrad from B school in CHK, and where I got my master degree from econ department before I go to US. And after my PhD degree, I taught in Singapore. And after during the COVID time, I come back. So I have been here for 5 years. I've been teaching this course for 5 years. So probably you could say I'm very well experienced for this class. And for this class, we have 2 TA. One TA, which will be your primary TA, Audrey. She will be handling all the grading on the Q&A. So if you have any questions, please feel free to send her an email, and she will handle all your gradings. And there is another TA, Ji Li. He will be doing optional tutorials, go over some assignments, questions, and some Python programming. As later you will see in our class, if you have ever looked at slides, we focus on Excel. And but of course, you know these days, and Python is so important, so he will be doing Python. Okay. So in the class, we're doing Excel. Okay. So just a very brief remind you what is about this class. This class is essentially based on all the basic stats. Right? Many of you will be the only class for the rest of life about stacks, because many of you are not doing any second course of stat. This will be the last course. And in the old days, 10 years ago, when I was a student like you, actually this class is broken down into 2 classes over 2 semesters. But now, because of time constraint, we condense everything into 1 class. Okay? It was a 2 course of 4 credit, now become 1 4-credit course. So essentially, it means that we are trying to cram everything into 1 semester, right? Of course, slightly more difficult, but we focus on application, as you can see the last sentence, rather than math derivation. Of course, in our exam, we will have some math, but overall, the thing is not math oriented. It's applying some math. So we are not going to worry about the math, but you have to understand the logic behind the math rather than there's a math. As you will see in my assignment or exam papers on every assessment is emphasizing application. Okay. And same as all the other sections, you have to is to learn the basic language of statistics, which will be very essential because with now the AI is so easy, you can ask AI to do almost everything, right? But you know AI tend to hallucinate, so they give wrong results seeming to be correct, right? So the main thing is not to ask you to conduct the math, right? But rather you can read it, understand whether they do it right or wrong, right? Of course, they don't worry about the machine will do the calculation wrongly, but they may apply the wrong calculation, right? Or the wrong method if they know the right thing, okay? And we will be talking about some important thing about normal distribution, about the bell curve. Probably you learn it from your high school. So we'll give more foundation to that and understand why we need to learn the bell curve. okay? And using the data to make some inference, or what we call use the data to tell some story, and that require you to learn the bell curve. Of course, the bell curve doesn't apply every single moment, but in this class, we assume the bell curve apply. If you want to see the case where bell curve doesn't apply, you'll be beyond this class. Okay? In fact, right, why the financial crisis in 2008 happened is because people think things are below the bell curve, and financial crisis is where bell curve fails. Of course, if you want this to be applied to some more real-world phenomenon which deviate from normal, then you will have to study further. But in generic case, this will apply. Okay? And number 3 is what we call inference tools, which means that we use our data to make some decision, right? Because now we know big data, right? Everything is belong to data, right? Data will tell us what to do, right? It's not something we think is right. Every decision should be supported by data because data is so convenient now, right? These days, you know, the manager, if only require intuition or business sense, will not work very far without data, okay? So everything, what we learn in this class is data-driven decision making, okay? So you have to learn how to use data, right? And when to use it and how to apply it appropriately. And that's the come to the 4th thing is try to see if you can use the data tools to solve the problem you want. Okay, this will be assessment later. We see the group project will be aimed for this one. You work on a project that you may collect data by yourself or rely on some secondary data and to do some data analysis. And so I said at the beginning, in this class we cover Excel. In the optional tutorial, you will study Python. Okay? This is the main topic we will cover. Same for all the sections. And probably the first 2 will be somewhat you know very well from the high school, at least at some level, right? Some statistic is something like mean, variance, this kind of stuff. We'll cover in this week. Okay, some basic thing, and we'll talk about probability. Okay, and probability by itself is very useful. If you come from the background of science, you learn that, right? And everything can be in science or physics at least, or chemistry. Everything can be described in probability world, right? And probability modeling is very important if you learn from finance, right? Because basically the finance is basically probability modeling based on that, right? Or option pricing, right? Back-Scholes model and all these things are probability modeling. Okay? And that is the first 2 topics is you probably learn something from the high school. Okay? And up on the distribution one is more like way more abstract than probability. Is the way that you try to put some method model, okay? Put some equations on how to model some situation. And this part will be useful when you try to model things, right? Say, for example, you're in Hong Kong, you know typhoon, right? How typhoon comes in and the observatory calculate what's probability that they will have typhoon number 8 and so on and so forth, right? How do you calculate that? It's based on some model, right? And this is some simplification of a very abstract, very complicated world. And that is belong to that area. And this first three thing, okay, is not really data directly, okay? And the next 4 topic will be focusing on how can we use data, right, which is limited information, okay, to draw a conclusion that try to hold for everything, right? That's we do survey, we do questionnaire, right? What in the earth tell us if we want to know things happen in Hong Kong, why we just randomly ask 100 people or 1,000 people? Can we say everything about 7 million people in Hong Kong, right? We look at a small fraction of it. How can we extend the knowledge we obtain from the data to conclude big things, right? Small to big, that is the data, okay? And that's why we need to learn probability, right? Because when you try to draw things, right, it's probability. So we want to go back. Okay? So that's the idea. And here we have 2 important topics. It's called estimation and hypothesis testing. Right? Estimation is basically the idea is, well, we try to estimate things based on the data we have. Where suppose I know, collect a sample of people, how many people earn much, some amount of money, average salary of them, right? We try to extend this knowledge of average salary to general idea about Hong Kong, right? So that's the idea. And hypothesis testing is somewhat related to that idea. It's the idea that we have some knowledge or some thinking about what may happen in Hong Kong, right? And use the data to validate that, test it, okay? And the very last thing, regression analysis is probably the heart of this class. And if you ever want to study statistics further, which is DOTE as 2021, the whole semester will be devoted to this one. So what is regression analysis? Is basically you try to build a model to understand how things are related, okay? Because we want to study cause and effect, right? How change in X leads to Y, and this is what we do. And probably you learn ChatGPT, right? The AI, all the AI thing. In some sense, it's regression, basically, right? You give some data and try to give you some result. If you ever learn about ChatGPT or all this kind of model, neural network or all the things, is basically regression. Of course, it's more complicated one. Okay? But you can imagine everything is very common and fundamental. Okay. And the next is the assessment scheme, which is going to be the same for all sections. Okay. 40% will be exam. Okay. At the end of semester, the TA will later after the actual period will send you the email telling you that or asking you the preference of when we'll have the exam, because I'm teaching the F and G section will be the common exam. It will be an open-end exam. So it's an open book exam. So you can bring whatever you want, except your computer and your phone. So you can print whatever you like and bring to the exam theater. Okay. There's open book exam. You cover everything in this class, except Python. Python is optional. So everything in my lecture slides will include. And the second component is 30% is called integrated assessment. In my class, it will be implement full group project. Okay. Later, I'll elaborate what group project is, but you will be applying what we learn to a study, which I will elaborate further. And the third part is content assessment, which will be a series of problem sets, and also quizzes. So later you will see what will be there. Okay. And the last one is participation, which we will do for that. Okay. And the descriptor is fairly common, so same as all the class as well. So the required textbook, which probably you will find in the bookstore, will be the book that focus on Excel. And since this class is very basic, so whatever book you would pick will be fine. Okay, at the college level, or if you don't like anything, just go to the web and look for the concept that we discussed. Should be fine. I don't think you will need a textbook for our class, but if you ever need anything, you can pick up this book. Or as I said, any book would work, because we don't rely on this book. So if you have all the slides, then you'll be fine. And we have a cost valuation, teaching valuation at the end of term. And I think during every class, in the middle of the class, at the break, I also put you reply that you can tell me how well you're thinking. And this will be the schedule. The first week will be the topic 1 and so on and so forth. I'm not going to talk about that because probably is obvious. So everyone use AI, but You can't use AI for your homework to generate the answer. Okay, of course you can just ask. You should use AI, may ask some question, but you are not allowed to use AI to generate answer, right? So you can't put the PDF into the ChatGPT or the chat box and ask the answer. You should do it yourself, right? So that would be the thing. Anything that counts as a grade, you can't use AI, right? But it's sometimes hard because AI is inbuilt in some search engine. So probably when you type something, AI result comes out, and you may not even know whether this comes from AI or not, right? But of course, you can't explicitly use AI to generate your answer. And to be sure, I mean, if you try to use ChatGPT to generate math answer, usually it's wrong. So better not to rely on ChatGPT. And plagiarism, same as other class. So please make sure that if the word, especially the group project, you should send it to well guy. Okay? And everything will be very standard. I'm not going to go every single thing. If you have time, you can read it, but otherwise, very standard thing is there. Any question before I proceed? There's nothing I can change that much because we have 10 sections, and then every section is the same. So there's not much freedom we can negotiate on this one. So if you go to the Blackboard, you will see the reference book. One of the things that maybe I want to mention is I actually wrote the book for this class, which you can read online for free. Okay, you can just go there and you can just download that book. You can read the book online for free. So, but everything is basically based on it's an extension from the class lecture slides. So if anything, you can go there to see. But now, if AI and the thing, I don't think this book will be very relevant because you can always ask the AI. So I have another document in the Blackboard, which is here. There's a reference, teacher manual, that basically outlines the way that I handle the class. And you actually see what the thing cover in your primary school, what I think cover in senior school. If you do M1, actually you can see more than 70% of the materials are already covered. Okay? But of course, 30% you need to study. Okay? So you can see what are the cover in the junior school and senior school, and what are things that we may advance. So what are covered there, and or the important point here you can go over. Okay? So in case you want to read it, you can read it, but I don't see anyone read, but just for my technical reference. Last thing I want to talk about is research project, because it consists of 30% of your grade, which I think that will be the most rewarding part of this class, because by only working through some actual project, you learn. Exam, you may be able to learn something, right? Able to get some good grade by applying something to the project, to some problem set, but it's only through the project that you really learn. So you can, although a group project, so you can work individually or group of at most 6 students. You can work by own or at most 6. Okay. And if you form group, I'm not going to check free writing. If you figure out that your teammate is not working, you just submit without him. I'm not asking the group membership. Okay. So if that guy is not working, you just omit his name from his submission. So I'm not answering any request saying, okay, this guy's not working at all, so can I kick him out? No, you can just kick him out. Submit without him. Okay. And the report is very short. So it will ask you to say is you only do 2 pages for every person in your group. So if you are one-man group bank, that's 1 person, 1 A4 paper done. It's page limit. Okay. So if you think you're good enough, you can just give me half a page. It's fine. Okay. So it's a concise report like business report. So I don't expect you to write a lot. It's a concise statement. Okay. So you have 2 person, the page limit is 4 pages, means 2 A4 paper. Okay. If you have 6, then it's 12 pages. Okay. 6 papers. If you go beyond the page limit, I'm not going to read it. Okay. Just the thing. And probably you want to see what are the things and what give you some ideas. So you can look at the Blackboard. It's already there in the zip file. If you I think it's in the course content. You can go to the sample, which I got it from last year's sample. So this is let you see what is covered in the last year to give you an idea what you're going to do. So this is a project you can see. I said everyone can. This is a project that can be done by 2 people. I don't know. They give me 5 pages, but I think for the appendix, I don't count page count. So basically, it's just a 2 people group. They give me a 4-page report. Okay, and what they try to do is, you will see at the end, they do a survey. They send out a survey and ask how people they use Spotify. And you can think of a question or business question should be to look at it. Okay, so basically they ask this kind of question to see who are using Spotify in Hong Kong. Okay, so ask people, are you the user? What gender, age, where you are, how much time you spend, what kind of the music type you like, what is the experience. Then they look at online one, and then they you can see they do some regression, which at the end of the semester, which basically a scatter plot, you will plot over to 2 variables and study how they're related. Okay, and they want to see if you spend more time, are you happier? Okay? Just like people spend more time Spotify, are they happier or not? Okay? Very simple question. So and then they do some hypo testing, and this is so the question is some of the question they ask is it what type is it affecting? How much you're liking Spotify, or where you're located, where the Hong Kong, where you're UK, and see whether people like the Canton Pop. So this is a kind of question they look at, and whether male and female they spend the same time or not, right? With the gender difference over there. So this one example you can look at, and I try to look at the other one. And this one you can see is a 1-person submission, so you can see just 2 pages, right? And this look at Instagram, and the question is whether they like Instagram in Hong Kong, right? So it's very business-oriented. You can see it's very direct, just telling you that what is the research question there, okay? And directive data, and he's doing some, or he or she is doing some testing, okay? And whether male and female are different or not, okay? Is it more men in Instagram or female in Instagram, right? And trying to see how the number of users related to male and female, right? And the ages, right? So you can see whether you will expect, right? Older people is less likely to use Instagram. So it's a downward sloping, males like this, female like this. Okay, so it's this is based on the secondary source, right? Because this is data collected from the web. Okay? Do note that the project I put here is just illustration. I randomly pick it up. I didn't say this is good or bad, just to illustrate what kind of question I ask. Okay? So you need not follow that format, or you need not follow the question. I just randomly pick up some of the project done in the past. Okay? You can go ahead and read everything there if you want to. Okay? But that will be the idea of what we want. Okay? So Is there a question before we proceed? Yes, please. Unless, or you will, in general, get the same grade, unless you complain about in the middle, someone is free riding, and you prove it, otherwise I assume equal, right? If that guy's complete free ride, I can just ignore him, right? If that guy's not working a lot, then you can say. Or you can declare, you do this, he do that, then I'll give different grade. But in general, they'll get the same grade. Unless someone report that guy not doing and that guy admit I'm not doing, or everyone's complaining about him not doing thing. Okay? But otherwise, it'll be the same. I mean, of course, this is a business application or setting, so you expect it to know how to work well with your group mate, right? And you have freedom to form your group, and you can also do by yourself, right? And of course, I would adjust my expectation according to group size, right? So you don't have to form group. So if you think you're good, you can do it by yourself, and actually people do it by yourself, right? But of course, if you're trying to do something big, then probably you want to do it. Any further question that I can try to reply? So I guess this first class, we will do some ice breaking. And this I will try to do, as you will see, every break, I ask you your reply and tell me your progress, whether you get it or not. And then, because I know it's a large class, so I can't really talk to everyone. So I think it'll be good. The way to handle is you reply. You can fill that in. For the first class, this I will do it earlier because I don't think we have anything to talk for the first half of the class. So let's have a 15 minutes break. And during the break, you can walk around and fill that in. Okay. So let's have a 15 minute break. We will resume at 15 minutes later. So it will be 3:15. So in the meantime, as usual, I walk around, and if you have any question, you can talk to me. But feel free to go to washroom, have a water break. Okay. Doesn't work. Okay. Let me check. Is it going to work? Let me try. Let me try again. Sorry. to see if it works or not. Okay. It's very funny. Let me end this section. Okay, maybe. Okay. Oh yeah, maybe I did this one. Okay, let's try. That's okay, fine. Please come to me so that I know you governance. How can I adjust? And for every part, every part, every thing you know, LS, how you not, how to do, and that. Not one to one is too much. So I guess we can slowly start our class. As I can see people coming in. So let's see the result. Okay. This is the first day of our class. Okay. Already 14%. Most people of you feel tired, surprisingly. Okay. And in this survey, you can see a good illustration of today's class. Right. We do a survey with the data and represent by graph. Right. Because the graph is the most visual one. Of course, the graph can be deceiving, so let's look at numbers. Right. So that's very important, and you will see why we're doing that. But luckily, nobody's very angry, right? But some people are sad, excited, and happy. Actually, add up to 40%, right? You add together. And tired is, I don't know why you're tired, but you can see also tired, right? You can see also get some coffee as well. Hope that you don't feel too bad. But this class is compulsory, and statistics may not be liked by everyone. I mean, I know everyone hates it, especially from my past experience, accounting students hate it so much because they can't see why they have to do it, right? But if you do audit, you do some sampling, you will need it, right? At least you know why we're doing that. And it's fair to say accounting people hate statistics, and because I also hate accounting class, so it's fair. Yeah, good. So let's see next question. How you are? So why are you here? Surprisingly, 6% of you think they like morning class, but today's afternoon. But I guess it's we are meeting on the Wednesday. Is it Wednesday? It's Thursday morning, right? So that maybe makes sense. And 3 of you actually said you already enrolled this class because your friend also do it. So that's good. Okay. I hope 3 of them are friends. Otherwise, it would be too one-sided. 9, which is very common, is because you don't want to come, but there's no choice. But that's life, right? There's nothing you can do. You have no choice to come. So the best thing is to try to make it happy as possible, right? What the Western people said, right? When you're lemon, make a lemonade. So I try to make this class as easy as possible, right? Open book, everything try to be easy, and then hopefully you'll do it. For 2 of you, if you want to go, no problem, just leave. You make no negative feedback to me. I mean, just you can leave whatever. And you're shopping around. Yes, but this year, probably you may know, in the past, different section with more difference, and this year we make more consistency and uniformity across sections. So shopping probably will not make much difference there. There's some difference between teaching style or thing whether we fit or not fit, but more or less material-wise or assessment-wise would be very similar. So we don't expect to shop around to gain something. But of course, if you like the other handsome guys, beautiful ladies in other section, please feel free to move around. I mean, that will help, right? Because with the fitness is very important, right? Because There's some handsome guys in other section and beautiful ladies that will help, right? But I can help you to concentrate in the class material, right? So I think that's important because you know what statistics, right? So the first one is, I think it's good, right? Because it's trying to look at the data and what the thing and take action. Okay. So more or less it's the data science, right? Just basically that. And this is also right. Use data to predict, to make decision, right? Of course, one thing is also more is how to collect the data, which is not studying a class, which is the most important thing, which we can't talk about in this class. And turn out, if you look at Elon Musk or all the AI people talking about is how to get a good data set, right? Because with a good data set, even AI cannot generate good thing, right? So that's why a lot of people, I mean, in the AI company, basically generate good data set, right? And that's applied to your project as well, but we don't have time to go over how to do the proper sample, how to clean your data, those kind of stuff. Okay? But of course, for your application, you don't have to worry about that. But if you really apply things in the real world, you want to make decision, then have to be very careful because we know garbage in, garbage out. If you get the wrong data, then it's not going to work. Okay? Yes. This is okay. I think this is from Wikipedia. This is too perfect. Or maybe you are a genius. Okay? But that is actually the right thing, right? It's collect, organize, summarize, analyze, and draw conclusion. Actually, this is what it is. It's a perfect answer. So if you do it from your head, you're A student. If you do it from Wikipedia, Google, then you're F student. Because I asked you not to do it, right? And yeah, it's good, right? Wow, a tools to the human being. I would say statistics also can study germs, animals, plants, okay? Even for the space, so that thing also work. Not just human being, not just living thing, also that thing can work. You study physics, right? Actually, regression is used to extend a lot of theorem there. Yes, big data, basically just the same thing, but with a lot of data. Right? But there's nothing, actually, no different from our class from big data analysis, right? The difference is the same thing, but with big data, you have more funds, more tools to apply, right? But there's nothing special about big data. Okay? If you apply regression, which we covered in the last topic in our class, to big data, actually you get AI. Okay? Of course, with some way to handle efficiently, right? Because what is AI, right? It's just billions of parameters of things. It's a regression, right? Yes, math model, and data. Yeah, it's about numbers to discover pattern from history. That's good, but probably you learn that the history doesn't represent the future usually, right? It's usually, but that is very important. That is for protection, right? That's what big data is, right? AI is going to do. Calculate, manipulate data, sorting out numbers, get a pattern. Yes, exactly what it is. Oh, I think I like this one. This is what you get, right? I've expanded this answer. Many numbers and many calculations. Yes, exactly what we're doing, right? So, and this is the things, if I were you, that's what I think, right? If you're able to answer that, probably you can graduate already, get an A from our class. Number 4, how well do you know? Okay. So no one think they're good enough. Okay, although someone already got the perfect answer. And I have some pessimistic result, right? 6 of you disagree that you learn. So don't worry, we start from scratch. Okay, and assume nothing but some basic math. Okay, you know how to add, how to subtract, how to do division. Then basically you're done. Okay, we don't require you to do calculus or what. I mean, there's nothing beyond basic arithmetic principle you learn in primary school. Okay. I like math. Oh, good. I have one people like math. Some people don't like. That's okay. Some of you may know I have 2 children, and my son likes math. My daughter hates math. So I spend a lot of time in the summer trying to convince my daughter, which 2 years, now is 7, to remember multiplication table. 1 times 1 equal to 1, that thing. I mean, I spent whole summer trying to convince her. Not until the last few days she tried to do something, but if she doesn't like math, it's very difficult. But my son is very easy. Just take a week, he can memorize the whole thing. But my daughter take whole summer, still can't work. So if you hate it, hopefully that you still like the idea that after this class, no more math, right? So the last thing in your life is that class, right? So hopefully you will be, at least you will happy. You don't like computer programming. Okay. So very surprising, but luckily we only do Excel for our class. Okay. But I think some of you, many of you should be trying to like programming, because these days we need to run AI. Okay. You don't have to do the program because AI can help you, but you have to understand the logic and how to apply. And this will be matter a lot in the future, because a lot of work will be replaced by AI. If you don't know how to use AI, that would be a problem. Or you do the programming, that would be some issue there. But anyway, I'm just your stat teacher, so you'll be your academic advisor, tell you what to do. Okay, not your dad or mom. Some people know Excel and M.Phil doesn't know anything. Okay, so don't worry, we start from scratch, from the very basic Excel. There's no assumption that you have to know everything. Okay, unfortunately, when I was an undergrad, the first year we have to take the computer literacy exam, which require you to know how to operate Excel. I think now that they remove it. When I was undergrad, I have to know how to use the Office program, Excel, Word, I think SS and those kinds of things are part of the assessment before you go to year 2. But now they are gone. Excel B.B.A, no one knows. Luckily, we are not going to talk about that. But eventually, you probably need to do it, because Excel is not that fast, and probably you need to rely on AI. Either use Python or B.B.A will be the same idea. So some people know SQL, and there's no nothing. We will have a Python optional tutorial, which will be conducted by one of our TA. Then if you go to that class, you will learn Python. Okay, of course, you can look at any YouTube and learn Python, but he will be talking about things that with our class. For me, I talk about all the Excel. Okay, and in that class, please bring your laptop or iPad to the class and learn. Okay, you can work on it. But of course, your phone will work as well. So if your phone, install your Office Excel, or I think the Google Sheet also can work as well. So just bring, at least, I think everyone has smartphone, right? So at least you have smartphone with you. Okay. So I guess that's the end of our survey. We'll do this kind of survey every time to ask you to give me the feedback, how well you're doing, and ask questions, because I think in Hong Kong, students, we used not to ask questions. But this is college, you should ask questions. That's why I walk around to talk to you guys, but you guys are still a bit shy. But I think after a few weeks, you may try to respond to me more. But so let's get started. Okay? If you don't have any further questions. So let's start. So statistics, in our class or in classical way, usually divided in 2 different sections. And as I said, actually, this is what used to be when I was undergrad. The first semester focused on the first part. The second semester focused on the second part. Okay. The first semester basically is what is called descriptive statistics. What does that mean? It means that if you are given data, how to get the use of it, how to get information from the data, condense the information data. Okay, nothing is created. You get From data, no new knowledge, is a lot of number, so make sense of it. What you get is called descriptive statistics. And there are two ways to understand the data. One is numbers, which we call numerical representation, which you learn in the primary school. And the second one is called the visual representation, which you learn in the kindergarten, the pictogram, right? You try to summarize it, right? You draw a picture, how many things you have. You draw an apple, two bananas, right? 3 oranges, some kind of that, right? Those is called the pictogram, right? And then you also see the bar chart we just showed you, right? So there's two things that will be the thing that we cover in the first week. And the second part is called the inferential statistics, which is this core content of second half of our course, which is trying to get from some data, we try to generate the knowledge from that data to much bigger thing. What do you mean? Is we want to study something which is very big, say Hong Kong, right? If we try to talk to every people in Hong Kong, we know everything in detail, right? But very often we can't. So what we're going to do is to try to talk to some of the people, right? And then use that information from some people to generate or to guess what happened in the big picture, right? That's what we do, right? You try to see what's there and try to guess, right? And remember what we said is look at the past to predict the future. The same idea, right? Because you can imagine that parallel universe, there are many possible of the history. We only observe one of them, but we want to use that to predict the future, right? So that is the idea, right? Use limited information to guess what happened, right? So everything is like this, right? Or some of you are doing accountant, right? You, of course, a client tried to claim he or she had this much of inventory. You need to check, right? Of course, you can check every single stock in his firm, right? Then you can say, you can attest that, right? But you can't do it, right? So you randomly pick up a warehouse and randomly pick up some location, right? And check whether it's valid, right? And try to infer if everything you collect is right, then you are going to be okay, right? So the same idea, right? So you can never be sure, but you have to make some decision based on limited data, right? So I would try to give this metaphor, right? Suppose you are in the romantic relationship, you want to get married, right? You want to make sure that the other guy or the other girl is going to be good, right? How can you make sure that guy or girl is good, right? You have to watch him from his birth to his death, right? Everyone body die, right? So you can watch his whole history, right? What you do is look at the past. In the past, is he or she loyal, right? Is he or she good to you? And so on and so forth, right? Did he or she remember your birthday? Did he or she give you gifts? Send flowers? Or not, right? Then check every single checklist. Tick, then you marry, right? So the same idea, right? But you can't be sure for everything, right? You can't hire a detective to follow him every single minute, right? So you can just try to look at some signals, right? Whether check the box, right? The same as this class, right? Some of you shopping around. Whether you like this class or the other class, you just have to see me here, right? Whether you like it, you keep. You don't like, you go to the other class, right? So you can't see the whole semester before you decide to take or not. So that is the idea, right? That is what happened, right? And in marketing, the same, right? You can't ask everyone whether they like your product, right? You just try to pick up some people whether they like it, and you do some analysis based on that, right? So that's the idea. And so now we start. Standard is about data. As we said, garbage in, garbage out. And this only slide that we talk about data, which is very important. Later you will see, but that usually there are two ways to characterize data. One is called categorical, the other is numerical. Let me talk about numerical first, because numerical is the one that you would use to face it in the primary school, right? The first one is count data, 1, 2, 3, 4, 5, right? How many children you have, how many boyfriends you have, how many girlfriends you have, right? Can be 0, but cannot be negative, right? Or can be more than 1, right? Can be 100, right? Whatever, right? It's count data, right? And can be continuous, right? Stock price, temperature, right? But say how many girlfriends you have, cannot say 0.5, right? Can be either 1 or 0, right? 0.5 doesn't may make sense, but usually we don't count, right? So this number, and this is no problem. Usually business you deal with numerical, but very often we need not be numerical, okay? And sometimes you can see they appear in number, but actually not number. For example, the first one is called the gender, right? You will see in data, sometimes in the data set, there's a variable called gender, and sometimes called female, okay, or male, and it's either 0 or 1. 1 means male, 0 means female, all right? And in that case, 0, 1 doesn't mean anything. 0, 1 just represent it's male or female, all right? And then you calculate that number, do some addition, subtraction, calculate mean, doesn't mean anything, right? So why we do separate the two? Because you do calculation on, say, average, mean nothing, okay? You don't do number, you can do some calculation, it means 0, okay? And it's most deceiving for ordinal data, okay? For example, very often we go to any website of marketplace like Amazon, eBay, Taobao, Tmall. They often give you the 5-star ranking, average ranking, right? 1, 2, 3, 4, 5. And people say, okay, this seller has a ranking of average ranking of 3.8 or 4.5. What does that mean? Usually mean nothing, because average has no meaning in that context. Later you will see average is what? Later you will see somewhere in the middle, right? But the middle have to meaningful, have to be add and subtract. With average usually means very little, okay? In that case, you should use median, which we will talk about later, okay? Using average in that context is a lot misleading, okay? Of course, it means something, but it doesn't have the property that we want to have, okay? So, and the next slide is the only slide we talk about visual representation, right? Because when I said there are two ways to do it, either visual or numerical, okay? But I guess you learn in your kindergarten, primary school, secondary school, how to draw a graph in the data, right? So I'm not going to repeat it in the college level. I mean, if you are interested in it, go to the YouTube and figure that out, or because it'll be simple. And also Excel, you can do it quickly, right? I assume you know to do it. If you don't know, then probably I can ask the TA to cover in an optional tutorial if you let me know. But otherwise, I assume everyone how to do it, okay? And for example, you know how to use bar chart, pie chart, histogram, polygon, okay? But do note that bar chart and pie chart have to focus on discrete or categorical, right? As you can see actually from the data we have, right? These things, right, are related. So that's why I have to put a bar chart there, right? This is not histogram. When we talk histogram, it will be continuous, it's related, okay? Okay, and polygon is just collecting the top point and collect together, okay? I think you learned it in the high school, so I'm not going to cover a lot on that. I assume you know how to apply it, and you should be able to do it nicely in your report, okay? To present your data effectively, you should use graphic and chart nicely, which is not covered in this class, but you should know how to do it. Okay. And the last two will be actually, we'll talk a lot in this class. Okay. And you will see, actually that turned out to be the main thing, is to show how variables or how things are related, because scatter plot. Okay. Later you will see. Actually, you see from the example I give, in the projects that are done by others, this, let me make it bigger. This scatter plot. Okay. This scatter plot tries to tell you that in a two-dimensional framework, how the time people spend on Spotify related to their experience, how satisfied they are. Okay. And in general, you can flip around the axis, shouldn't change anything. But usually, later you will see, you probably want to try to say how this is the cause and the vertical is the effect. But in our class, we are unable to establish cause and effect in our class. If you want to do it, it will be a graduate level thing. Okay? Basically, Ph.D. or master people will try to learn how to establish causality. In our class, we just establish correlation or how they are related. Okay? Causality is a very complicated thing, but that will scatter plot. Okay? And line chart will be similar to what we have here. Okay? And you learn, look at the stock price chart, the line chart there. Okay? The x-axis is the time, y is the price, right? Same thing. So I'm not going to go into details. If you want, you can just study by yourself on this one, because it's too elementary to cover in the class, and it will be very boring, right? Because this class is very boring, so I don't want to make it even more boring. So now we're going to more interesting thing, right? It's the core of this class. This is going to give you a number that tries to summarize the data. Okay? So this thing is, you're given a data set. Okay? You're analyst. You try to tell me what happened in data. Okay? Your boss is very busy, so you just give him a few numbers. Okay? The first type number is telling your boss what happened. So that is what we call the central tendency, a single number that tells us what happened in that data. Okay? You learned it in the undergrad, in a high school or junior high school, right? You learned it, that's the mean, right? Average, or median, or mode, which we'll cover a little bit further later. And the second type is once you give your boss a number, which mean, median, mode, depending on the type you said, is the boss asks, how good is that number, right? You give a number, but how good it is, right? Then it's called dispersion. Okay, it's how accurate is that, all right? That is the variance, then deviation, range. We'll talk about that very soon. Okay, and this thing actually covered in the in your high school. Okay, last one, the shape. Okay, which is relatively advanced. I don't think you're covering the standard material in the high school. It's new. What we call is called the two things there is called the skewness and kurtosis. Okay, skewness is whether they're symmetric about the mean, and kurtosis is whether the tail is a fat. So it's like, is there a lot of extreme cases or not? Okay, so that would be the idea behind. So basically, it's just there are several types there. I think we'll cover the first two types, and we will left there for the first day. Okay. So is that clear what we're going to cover? So this first week we covered these three types of numbers. Okay. Remember the question is, your boss gives you data. you tell your boss what's going on. First one number summarizes data. Second one, how accurate data is. How accurate the number you give your boss. The third one actually give more feature is the depth number, right? Because the one is you give the mean or median, right? Looking at whether data is symmetrical or not, right? Is it more likely to be skewed to the left or skewed to the right? The second one is whether the tail is very fat or thin. Okay? We'll be more clear for the second one, the third one. The first two probably you know pretty well. So let's look at the first three things, mean, median, mode. I think it's very trivial, so let's go for it very quickly. Okay. But before that, with some notation, because this notation will help us to keep our formula easier. Okay. And this is all the standard in all the textbooks, so that's why I try to be more forthcoming. We use this small letter n to denote how many data we have. And each observation will be a small x1 up to xn. Do note that the small letter and capital letter are different. And when you go to the next chapter or so, the capital letter means other thing. So we use small letter for data. And here comes the most challenging notation, is the summation notation. It's adding. The summation is the Greek capital letter. Greek capital letter. Okay, it's called summing. It's adding. You can see the summation side. Sum. Okay, it's adding from 1 to n. If you learn computer science, it's a for loop. For I from 1 up to n, you just every time increment by 1. So x1, put 1 there, and then x2 up to xn. So this is the notation that you often see because it's shorthand to make our life easier. Okay, because I write in slides, so this is easier. But of course, you can always write that down in the long form. Okay. And here comes to another two functions that often you will see in make our formula easier. Okay. And the first one is called round down or the floor function, which means that we take away the common places. Okay. 3.1 is 3, 3.99 is 3. 2.9999 is 2. Just take the integer. And ceiling is round up. Okay. It's just the next bigger number. Right? So 3.1 is 4, 3.99 is 4, and 4 is 4, 4.01 is 5. Okay? So just make our life easier. But I don't think this will be something very big there, but this is the notation that we use, and hopefully it will be clear. And there's something that we call the data handling. Okay? This term. And if we put the data from smallest to largest or other way around, it's called sorted data. Okay, everything is sorted from small to large or large to small. And usually we put ascending order. Okay, now place. And another term we talk about is called frequency. Frequency. Frequency is how many times that number appear in the data set. Okay. So for example, if data 1, 2, 3, 4, 1, 2, 3, 1 appear 1 time, 3 appear 1 time, but 2 appear 2 times. And the next is what we call the relative frequency, which is relative number of them. Okay. And in that case, 1 has relative frequency of a quarter, 3 has a quarter, 2 has a half. Okay, is that clear? So this is something, nothing new, but just some notation what to mean by frequency and relative frequency. And this is what you learn in the primary school. Is have the frequency table. It's counting number of them. Just draw them table. X has 3 values, 1, 2, 3, and f of x is 1, 2, 1. Okay. So basically, what it does is, in this context, is you change data to a function, right? If you learn what function is, right? Function is like collecting mapping from a number to a number. In this case, right? You give me number 1, I tell you 1. Give me 2, I give you 2. Give 3, 1. Okay. And the last one we talk about is called the contingent table. Okay, is to collect numbers. Okay. So in this case, what do we mean? That is, here we have 80 students, and look at how they pass or fail in this class. That means that there are 15 male that pass this class, and there will be 20 female that pass this class, right? And 25 male that fail this class, and 20 female that fail this class, right? And 35 is adding the columns, and the row are adding the rows, okay? End of the row, adding the row, end of column, adding the columns up. So later you will learn this more in the topic 2, but I just put it here first. Okay. So this ends our notation, and hopefully we go to the definition of mean. Okay. Everybody know what the mean is? Adding everything up divided by how many of them, right? There's nothing new, right? Just sum divided by number, the count, right? The notation is summing up from 1 up to n, so this is no notation. Okay. Of course, everyone knows it. So what we're going to do is telling you what exactly it means, right? Because why adding thing up divided by n? What does that mean, right? Why add things up, right? Why we add things? Why we don't multiply? Why we don't do something weird? We have to understand why we have to add them up, and that explains why when we can use a mean. Okay. The first property is coming from the following. It means the mean is exact location that look at the mean to the left and mean to the right. The distance are the same. Okay. So let me forget about this. Look at the graph, because I think you will not get it from the math, but the graph. Okay. This graph illustrates you have 4 data points, 2 red and 2 blue. Where's the mean is? The mean is a black dot there. What I meant is mean is actually located. Look at distance to the left of the mean, which is the red one. Okay. It's the red distance. It's this distance plus this distance. It's left distance. And the right distance is this distance and plus this distance. Okay. What it means is they add up to 0, right? But on the left-hand side is positive, and the right-hand side is negative. That means that is sum of the right is equal to sum of the left, so they cancel out, right? So that means that the mean is exact location that you go to the left, go to the right, same. So let me repeat. The mean, you can move this dot left and right, move around. If you stop at location where the left distance, which is red, same as the distance on the right. Okay? And of course, this only makes sense, the distance makes sense. All right? So that's why I said when the ordinal data doesn't make sense. Because when you talk about ordinal data likelihood scales, how much you like this 5-star, 4-star, 3-star, 4, 2-star, 1-star. The difference between 3 and 4 is not the same as 4 and 5. Okay? If you say 3 and 4 are the same, you can do it. If not, you cannot do a difference. Okay? Only if you make sense to make a difference. Is that clear? So let me repeat if you don't get the math. Basically, mean is exact location. We're looking the data from mean to the left-hand side, the right-hand side, the same. That's the mean. Okay? So it's basically it's the center by distance. Remember, it's called why? Because this is representing data, right? Remember what's the use of mean? It's use the mean to represent the data set. So it's where actually the data is, the center of data by distance. Okay? So I hope that's make it clear. And this example, I think it's very easy to see. 1, 2, 3, 4, 5. You add up, it's 15 over 5. That is 3, right? And the next one is 1 plus 3 plus 4 plus 50, right? There are 5. 60 over 5 is 12. Okay? You can verify that. And why I need to show this simple example? You can see that if I change the last number, 5 to 50, the mean expand crazy, right? So mean is very deceiving, right? Why? Because I'm very poor, okay? But the salary of me and Li Ka-shing or Yun Ma add together, Jack Ma add together, we're very rich, right? So there's no point, I mean. And that also means that when we call it mean, look at extreme value can be very deceiving, okay? And that's why mean has some problem. Of course, if you have very big data, it should be fine, right? But you have to make sure that you don't include some people that is very rich when you calculate average salary, all right? So, or average data, have to be very careful. And you check data, if there's outlier, or the outlier means the data that far away from the mean, okay? If you have those data, you should look at it, are they valid entry, right? Because 50 can be the reason that you typo the guy entered data. So that's very careful when you look at the mean. Although it's very useful, but you have to be very careful about this kind of problem. Okay? And just to remind you that for a class, it's essential to understand the blue box, which is the main idea I'm going to talk about. And all the gray box is for your understanding. Okay? I'm not intended to ask question on that. Okay? Any gray box is for your fun. Okay? If you forget about it, no problem. Okay? It's not intended to ask in any exam. Okay? Maybe asking in assignment, but it's not the main thing there. And the green thing, you should know very well, because that will be based, it will be our assignment on our exam is based on that. Okay? You should know the green thing, at least understand what's going on in the green thing. And some technical thing is, quickly, I don't want to go to detail, is how in the world, when you have a data, how can you handle this kind of stuff? Because you can see one drawback of the mean is up to the outlier. In the real world, how can you solve this kind of problem? Okay, is you want to say your data, your average or mean, doesn't subject to outlier. How can you do that? The way to do it is to calculate what we call the trimming mean or winsorized mean. And to show that your mean doesn't change a lot. By trim mean means that you take away the outlier. Usually you take away the top 5%, bottom 5%. You calculate mean again. If the same or similar, then you're fine. Okay? So that is called the trim the mean, take away the outlier. Or it's called winsorized. It's trying to say if you have very big data, right? You have some data that is 1 million people, okay? Then you would put the top 5 people or bottom 5 people, replace them. What do we mean by that? Is because 50 is very large, you replace by 4, the next to it. Okay? Suppose you're 100 people, 96, 97, 90, 100, the largest these people, we pay by 95 people. The bottom 5, 1, 2, 3, 4, replaced by the 5th guy. Is that clear? So the first 5 guy, the data replaced by the 5th guy. 96, 97, 98, 99, and 100th, replaced by 95th people. That's called the winsorizing. And you want to show that the winsorized mean and the trimming mean are very similar to the raw mean you calculate, then the number given to the box will be fine, right? If these numbers are very different from the raw mean you calculate, then you probably try to give this kind of data would be more helpful to your boss, right? Because you don't want this thing to change your result. Okay, this is how things apply in practice. Okay, but it's beyond the scope of a class. But you should try to do it when you have a large set of data. Okay, but for our purpose, you can ignore it because I said this technical. Everything technical, I just put it there for your fun. Okay, and I wanted to talk about this because this is something you know very well. It's called the weighted mean. Okay, and weighted mean means that not every observation the same. Okay, some observations are more important, right? That happened for your GPA, right? Why you need to study this class more than other class? Because we are for credit course. Compared to free credit course, we are more important, right? Because when you calculate GPA, our weight is 4. Other class weight 3 or 2 or 1, right? So the A is more important for our class than the other class, right? Why this is the formula, right? Because you would weight it by the credit divided by sum of the credit, right? This is how you calculate GPA, right? Similarly, when you go to stock market, the Hang Seng Index, right? You will see your big stocks move up a little bit, despite all the other small stocks go down, Hang Seng Index will go up. Why? Because the big stock move up is more important than the small stock. Okay, so that's the idea. Okay, and this is what happened in finance, but I don't want to go into detail. But this is what usually calculate. Okay, and this is the example that how you can apply. But I guess you can read it without any trouble. But just simple average adding up divided by total number of them. But when you're at the weighted average, then you multiply each number by its weight divided by sum of the weights. And you can see that this number is lower than this number because the low number 1 has higher weights. Okay, so that's why it's smaller. And I'm not going to go to technical detail here. I just skip. But just to remind you that there are many other averages beyond the adding up. Okay, you can have other averages called the geometric mean. It's multiply them all and take nth root of that. And actually, there's a nice property there. You would use geometric average rather than adding up. If you learn finance, that is how you calculate the return. The compound return, you would do it. I think you would learn investment class in required, and the first class is, I think, is 3050 or 3080. When you're investment class, you learn you will do geometric average, then simple average. Okay, and harmonic mean also used in finance. When you have two companies, you have the PE ratio, price earning ratio. You want to calculate the combined one, you use harmonic mean. But these are beyond the scope of our class, so just for your own fun there. And this gives you the idea that why you care geometric mean. Okay? If you want to look at it, look at it. I don't want to talk about them because of the time. Okay. Now, next is once the mean. Okay. And I said the mean doesn't apply to ordinal data, right? So what you will ask is, okay, if mean is not the best, okay, of course mean has some uses, but what is good about that one when we talk about the ordinal data? It's called median. Okay. When you have ordinal data, median is good. Okay. And median, the good thing is it doesn't affect by outlier, right? Median by construction is very simple. It's just data exactly in the middle. Okay, nothing more or less. Okay. But what do you mean by exactly middle is not entirely clear. Suppose you have 3 observations. The middle is clearly the second one, right? 1, 2, 3. Middle is exactly middle one. But if you have 4 observations, what's the middle? The second one or third one? Right? 1, 2, 3, 4, which is the middle, right? And by convention, when you have 4 observations, the middle is 2 and 3, right? So usually the thing we do doesn't make sense, but this convention is kind of average of these two numbers. Okay? Although I said average doesn't make sense. So that's sometimes when we report median, you may report two numbers, right? But in our class convention and many software, we give you the average of these two numbers. Okay? So the formula like this, if n is odd, right? Suppose 3, right? 3 plus 1 divided by 2 is the second one, right? And if n is 4, okay? N divided by 2 is second. Second plus 1, 3 is 2 and 3, okay? So like this, right? How can you do programming? Is through this function, okay? Is n plus 1 over 2, the half one. You take the integer part, that's for lower floor, and this one upper part plus 1. So this formula. That's how you would do it in software, okay? But of course, you know how to operate that. So as we said, the meaning of the median is exactly the middle, right? So that means that it's center one, okay? It doesn't really matter what happened for the rest of data, right? No matter the rest of data increase or decrease, except the middle guy or middle two guy. If it doesn't change, nothing changes, right? So that is the good thing about median. It's exactly middle guy. No calculation at all, except you just look at pick up the middle guy, middle two guy there, right? So that means that it applies to ordinal data, right? When you have data that cannot add and subtract, and this will be very good. Okay? An example like this, right? 1, 2, 3, the middle guy is 2. 1, 2, 3, 4, the middle is 2 and 3, average of them. If you have 1, 2, 3, 40, same, because the middle two guy is 2 and 3, average of them. Is that clear? Good. So we're done with the median, okay? So remember, just to remind you, here, the data, mean is good for this one. It's good for mean, right? And the median is good for this. Right? Median would make sense all of them. Okay? Well, naturally, the last question is, what happens when you have normal data, right? You learned that in the kindergarten. The real question you collect is, how do you go to school, right? I go to school by bus. I go to school by walk. I go to school by car, right? So you can't really give number to it, right? It's nominal data, okay? And then what happens when you try to collect data is mode, okay? That will be the thing. That will be this with the mode. Okay, that will ask mode, okay? Mode. And mode is what? Mode is very simple. It's just the most frequent data, okay? Look at data, which one has the highest frequency, and that's it. This one didn't involve any calculation at all, because median, you still need to add things, right? When the two number, you have to still order them, right? You have to order them from small to largest, look at the middle. And mode don't even care about, you can compare things. Just look at the number of category and just to look at the most frequent one. Okay? So that is the idea of the mode. Go back to here, the mode. Okay? It's most frequent. And of course, when you calculate the most frequent, it can be more than one, right? So mode can be more than one. Different from mean and median. Right? Mean and median just with one number. Mode, you can be more than one. Okay? And there's another complication is, in some textbook, it say if everything appear once, some textbook will say there's no mode. But we just use the convention in statistics software. When everything appears once, then everything is mode. just to make the notation easier. Okay, maximum of x, that maximum the frequency. So that is what we are assuming. So in this case, very simple. If everything appear only once, everything is the mole. If the second one is 2 and 3 appear twice, then 2 and 3 are the mole. And the last one is 2 appear 3 times, much more than the other one, mole is 2. Okay. Remember, the good thing about mole is, regardless of what the data is, you can always apply. So mole is always applying. Okay. So the easiest, right? Of course, it drops a lot of information, right? Because you can't compare things, so you can't do much. When you can do more, you can always use mean, right? When you do things, always use mean. If you can't do mean, you do median. If you can't do median, you do mole. Okay? Although we say there's a box inclusive, but you should always do mean when you can. Of course, mean and median and mole capture different things, right? Because mole is asking most frequent one. So there are 3 different kind of measure. And very often, the good thing is you want to give your boss these 3 numbers usually very close to each other. Then you're safe to tell your boss, you're very confident, no matter how you measure it, the same thing, right? So you will see in statistics, there are many ways to measure stuff. Okay, in this case, mean, median, mole. You really want 3 things to give you the same idea, right? If they don't give the same picture, you should go ahead to study more why they're different, right? And tell some story there. That will be the part of your job, right? If everything is consistent, same thing, then you don't have to do anything further, right? Is that clear? The 3 measure, mean, median, and mole. This is something in the primary school, so I think it's okay. Okay. So the remaining 4 minutes, I want to talk about range. Okay. Very simple. Next class we'll talk about the rest, but let's talk about range. So as we said, the second set of measure called dispersion is looking at how good your mean and median mole are. Okay. And by looking at this type of measure is looking at how spread out the data is. Okay. And the first one is called range, which is something simple, very simple. Is look at the biggest and the smallest and look at the difference. Do note that this only makes sense when you can calculate difference. So that means that this only apply for numerical data, right? That makes no sense when we talk about ordinal data, right? So if it's order, xn minus x1, right? And of course, this problem is affected by outliers. Okay, give example, 1, 2, 3, 4, 5, the range is 4. 1 to 50, the range is 49. So as I said, why need that, right? The first one range is 4, is small. But this range is large. So when you tell your boss, right, the range is very big, right? So that means that your average will not be very accurate in the second case. The first case, the range is very small, 1, right? So range is 4, right? So that means that this is rather accurate. So I still have 3 minutes to go, so I can talk about the last one. Okay. So since range is the biggest minus smallest, this distance, okay, is subject to outlier. So why we look at the biggest, smallest? Okay. The main idea here is happy birthday idea. Okay. Instead of looking at the data here, largest and the smallest. Okay. What you do is look at the median or the data. Look at the data. You cut in half. We cut in half the median. It's birthday cake. Cut in the middle. 2 half. Okay. And the first half, you cut first our data. You cut again. This is called the first quartile. Okay. And the second half data you cut again is called the third quartile, Q3. Look at the distance between these 2 subsequent cuts is called the interquartile range. Okay. Quartile means you divide things into 3 parts. Quart, right? Tiles mean parts, right? Tiles is the square. You cut the data into 4 different parts. How to cut things into 4 parts? By 3 cuts, right? First, the median, cut in 2 parts. Look at 2 parts, cut the median again, right? And look at the difference between the last 2 cuts. If these 2 cuts is very far away, then the data is very spread out. If these 2 cuts is very close to each other, the data is very condensed. Okay. Instead of looking at the large and smallest, look at the Q1 and Q3. It's your IQR. Okay. There are some formula difference. How to calculate exactly what do you mean by this cut and this cut, and you will see if you look at the software, at least there are 9 different ways to calculate that. Okay. In the high school, you probably learn one of the way, and depending on which country you're coming from, you will learn one of the way, and we'll focus on 3 different methods. Okay, one is the UK way or Hong Kong way, or the US way, the US one, and also the one we use is the standard in Excel. Okay, so we'll talk about that in next class. So see you on Thursday. Yeah, you can go. Thank you very much. Have a nice day.